Measuring correlation then. So correlation, if you remember back to our scatter graphs or just generally having some points of data, measuring correlation is about, what does this line look like? Is the correlation relatively weak, strong? Is it positive? Is it negative? Is there no correlation? Um, and sure, we can sort of look at a diagram, but we can use something called PMCC, correlation coefficient. In other words, some sort of number that describes the correlation. This number will always be between -1 and 1. Okay, and over here you have a positive correlation, and over here you have a negative correlation. As closer you get to 0, is sort of the weaker the relationship, and the closer you get to the extremes is the stronger the relationship. So that would be like a perfect negative, strong negative, in the middle, no correlation, weak positive, perfect positive, perfect positive. It fits the line exactly. And it says here, 0.7. If you're going above 0.7 or going below minus 0.7, that's when you've generally got strong correlation. So what have we got here? I think we'll just skip all of this one here. Let's have a look at some examples. So that would clearly be a negative correlation, quite a strong negative correlation. -9.1 is no good. Close to -1, perhaps. That's the only option. Which of these would have a correlation coefficient closest to 0? So which seems to have very little relationship between the x and the y? So it's B. Okay, there doesn't seem to be a clear sort of straight line that you could draw here. That seems to be a weak positive. That seems to be a perfect positive, and that seems to be quite a strong negative there. Okay, this value, you can actually find this value out on your calculator. And here, this gives you a guide to how to do it. So if you press menu and then you press statistics and you press option 2, you might notice on your calculator that there are other options. There's an exponential option, there's a reciprocal option, there's loads. So you can use other ones, but here we're just talking about linear for now. And if you press option 2, you end up with a table. So this table here, imagine this is sort of I could say your X and your Y. This is, let's call them the X and the Y. But I'm not using this like input output. I'm using this as like idea 1, idea 2. Okay, so 1, 2, 3, 4. And then on the other side, if you do 3, 6, 5, 8. If you're not sure what to do, then press on and then press options over in the top left. And then you can select what you're interested in. So when I press option, I'm going to pick 3, which says regression calculation. Okay. And that comes up with 0.868. So that's the number that's listed as R. So let me just say that again. So you type in your table. Once you press your table, press on, press option, press 3. It says regression calc. And then it will give you an A, a B, and an R. And this is the A that they're talking about. This is the B. But the R, which we haven't really seen before, the R is the correlation coefficient. So it's that number between -1 and 1 that describes the type of correlation and the strength of correlation. So this is a strong positive. And if you check this very small list of data here, that roughly seems to be true, doesn't it? That as that number on the left-hand side is going up, the number on the right-hand side is mostly going up as well. Okay. So there we go. It's just sort of a visual display of what to do. Mine is a little bit different. Mine is option number 3, a regression calculator on mine. So multiple choice, pause the video, type these ones in and see if you can get the R value for these ones here. So again, you're on statistics mode. So menu statistics equals 2, and then you've got your table. So you type 19, 16, 8, 12, and 20 all in the column on the left-hand side. And then for Y, 15, 10, 9, 9, 18. Press on, press options, regression calculation. I've got 0.856. So should be option here, should be option C. Okay. Another example here for you to have a go at on the board. Notice as look, teachers go up, marking time goes down. You can instantly dismiss C and B. There's a negative relationship between them. Okay, so it's either going to be A or it's going to be D. And I'll leave that one for you to work out. So here we've got another example. So what we might be expected to do is we might be expected to look at the correlation between these ones here. I noticed that we could tie in the large data set for this question. So not available, not available. What are we talking about? So we're talking about daily mean wind speed and daily maximum gust. From Hearn, state the meaning of NA. So data is not available. You could just say there's no data for that day, something like this. Calculate the PMCC for the remaining 8 days. So for the first 10 days, the remaining 8 days. So what do they mean here? Well, they're talking about if you ignore these ones. So if you do 1, 2, 3, 4, 5, 6, 7, and then 8, what's the PMCC value that you'll get? Well, you can put that into your calculator. Using your answer for B, comment on the suitability of a linear regression model. In other words, are we trying to do the right thing, trying to put a straight line on this and getting an R value? Is it appropriate? Well, what does this say? Yeah, it seems to work quite well. So it indicates there's a strong positive relationship, which means that your line, your model is going to be relatively useful. Okay, so links to the large data set, possibly using the calculator confidently and understanding a little bit what's going on is what we're looking for. So pause the video and have a go at this one here on the board. Notice there's a link to the year 1, chapter 4 pure, chapter 14 pure going on here. So it wants you to take some logs, copy and complete, calculate the value, state if it's a good fit or not. Okay, and then we've got another question here at the bottom. So pause the video and have a go. So these are our log values we should have found. A very strong negative correlation because it's almost perfect. It suggests the model works very well. Now, something that's a little bit tricky here. We changed the data so that it fit a straight line, but that data actually came from an exponential model. It's only linear because it was exponential and you took the logs. So we're not actually saying that a linear model works quite well here. We're saying an exponential model works quite well. The exponential model works well because when you take the log, it's linear and the linear is a good fit. So just something to sort of be aware of there. And then what we got for this one, find an expression for n. So they've given you the actual equation. They've said this is what the equation would be. And you might find that you actually have those values there from your calculator, A and B. So can you work to find the original expression, the original exponential equation? We did this in chapter 14 pure, so I'm not going to go over that one there. That's about taking the logs and matching the parts up and undoing it with power of 10. Okay, and that takes you to exercise 1B. So finding PMCC and be prepared for questions to ask you about logs and ask you to go backwards. So chapter 14 pure needs to be strong for this part here.